So in this particular bird's eye view problem, we have a car that's being towed by three forces given in the diagram here. Here in the diagram, it's just the magnitude of F1 is 383 newtons, the magnitude of F2 is 230, and then here we have F3 pointing in the southeast direction, which has a question mark. So part A wants us to determine the magnitude of F3, and then part B wants us to find the magnitude of the resultant, or aka the net force. So the subscript R here just imply the word resultant, but resultant is the same as net, which I have here in parentheses, net force, or the total force. It says if the line of action of the resultant is along the x-axis. So the car is just going to move straight to the right. It doesn't veer up or down. So that is important to keep in mind as you keep up with this problem, okay? All right, so let's go and knock this out. In order to find F3, I'll show you how to do this a couple different ways based on how you see the problem. I'll do this proper first. So the first thing I want to do is draw all my F's and their components. So here's F1, watch my cursor. Here's F1. I drew the length of my arrow about the same there, okay? So that's F1. It has to have an Fx component, which I'll call in green here. And then it has to have an F1y component. So F1x points to the right, F1y points up. And the angle here is 40 degrees. Keep in mind that you look at this diagram correctly from the x-axis all the way up to F1. That is an angle of 40 degrees because this is 20 degrees and then this is another 20. So 20 plus 20 is 40 degrees. So make sure you look at these type of schematics correctly. Don't get play just because it says 20 degrees in the diagram. Okay, so know where to measure to and from the x-axis up to where it touches F1 is an angle of 40 degrees. I'm going to do the same for F2. F2 here is 230 newtons. It is pointing in the northeast direction at an angle of 20. So it has to have an F2x and an F2y pointing right and up. And the angle here is 20. And then last but not least, F3. F3, like I said earlier, is pointing in the southeast quadrant. So it has to have an arrow F3x pointing to the right, which is east, and then F3y pointing down, which is south. Okay. Now that you have those, let's go ahead and crack it out. Well, the first thing I want to do is just set up an X and Y chart here. Why? Because it's important. This is a bird's eye view problem, so you should definitely set up your X and Y chart. This way your information is appropriate, and once you have that, I think the rest of the problem kind of just falls into place. Here I have net force in the X direction needs to go to MAX. So in this particular problem, I have three green arrows in the horizontal direction. F1x where my cursor is pointing. I have F2x and I also have 3x. All of these x arrows are pointing to the right for this particular problem. So everything is positive here. F1 is positive, F2 is positive, F3x is positive. So I'm just going to go ahead and find all F1x, F2x, and F3x. Okay. So according to the first triangle for F1, cosine of 40, which is adjacent, aka F1x over hypotenuse. Hypotenuse in this case for this triangle would be F1. So here I have cosine is adjacent over hypotenuse, which is F1x over F1. And then if I were to solve for F1x, I can just multiply both sides by F1. So here I just moved F1 to the top left in the numerator. So here F1 times cosine of 40. And then keep in mind that cosine of 40 on your calculator is going to give you about 0.766. And then F1, well, it's given the diagram as 383. Okay, so keep in mind that there's certain information given in the schematic here for you that's super useful. So if I punch in 0.766 times F1, which is 383, you should get a value of 293.4. And that represents F1x pointing to the right. So the horizontal component F1 is 293.4. And I want to do the same for F2x. Okay, so I'm just going to go a little faster here. Using the same strategy, except the angle here is 20, and cosine of 20 is 0.94, and then F2 in the diagram is 230. So if you put in cosine of 20, it's 0.94 of F2. If you put that on the calculator, you should get about 216.2. And then last but not least, the third triangle, which is for F3, I'm going to do cosine of 35, which is adjacent over hypotenuse. F3x is my adjacent, hypotenuse is my F3, and then boom. Cosine of 35 is 0.82. I don't know what F3 is because that's what the question is asking for in part A. So therefore, I'm kind of stuck here. I have two unknowns. I have an F3 that I don't know what it is. Therefore, because I don't know what F3 is, I cannot solve for F3x, which is fine. I'll leave it as is, okay? So it's okay to set things up, and if you run into a couple unknowns, don't panic. It's okay. Just think. So here, I'm going to go ahead and fill out the information I'm given here. F1X I just found, which is 293.4 on the bottom left of my screen. F2X I found 216.2 right there in the middle where my cursor is going back and forth. And then F3X, well, I found it as 0.82 of f of 3. Okay. So I'm just going to go ahead and substitute in for 0.82 f of 3 just to kind of show you how to do substitution here. However, you notice my work here, I have F3 and AX highlighted. The question never, or the problem never gave us an acceleration to play with. So because I don't know what A is, I don't know what f of 3 is, I'm kind of stuck here, okay? And the mass of the car is not given either. So you notice here, if you just try to set up the X information, you're kind of stuck here. You have a bunch of unknowns that you cannot solve. So here, I highlighted to me that the two more important pieces of information, and that is F3 and AX. I know M is not given either, but to me, F3 and AX is super important because you have to have those information, all right? So here, I said that you have two unknowns. If you want, you can say you have three unknowns. It doesn't really matter. The point is that you're stuck on the X side, okay, because you have more than one unknowns. Well, if you're stuck on the X side, use the information on the Y side. These problems are kind of designed so that you can kind of untangle them. So I'm going to set up the information on the Y side. I'm going to say net force in the Y direction is 0. Now, Y is equal to 0 because it sets that the line of action is along the x-axis, suggesting that the car does not veer upward or downward as it's being towed. It's just going to move perfectly to the right of the diagram or of the screen. Okay. Here, if you look at the schematic, we have F1Y pointing upward, which is positive. We have F2Y, which is also positive. However, F3Y is pointing downward. So in my work, I'm going to go ahead and keep all my positives first. F1Y is pointing up. I'm going to add that to F2Y, which is pointing up for this diagram. And then I'm going to go ahead and say that F3Y is negative. So I'm going to introduce my negative sign right away. So I'm going to say F3Y is indeed in the opposite direction by adding a negative here, okay? Which is the same as subtracting a positive. And I'm going to set that. I'm going to set all that equal to 0. So therefore, we know what F1Y is. We know what F2Y is. We can just solve for F3Y super fast. So the information gives us enough information to find F1Y. So if you look at this first triangle for F1, the problem gives you a hypotenuse and an angle, which allows you to find all the sides. So if I were to find F1Y, I'd have to use sine of 40. Well, sine is opposite over hypotenuse. Well, if you look back on the first triangle, here's sine of 40. Opposite is F1Y, which is unknown. F1, though, which is my hypotenuse, is known, which is 383. So I'm just going to solve for F1Y by using the same algebra stuff for cosine to get F1Y by itself, multiply both sides by F1, and then F1 being 383, sine of 40 being 0.643. So if you punch all this in your calculator, you should get a value of 246.2. So I just found what F1Y is, okay? So that's one of the variables that I have here that's known. Using the same strategy, I would just use sine of 20 for the middle triangle, and then to solve for F2Y, if you punch it in your calculator, you should get a value of 78.2, okay? So F2 being 230. And then last but not least, we're going to set information up in the Y direction for the third triangle here on the right where I'm circling, right? So ultimately, we're just trying to find F3. But to find F3, you have a triangle here with one angle, and you have three legs that you don't know. So that's not enough information in geometry. You need at least like an angle and a leg or two legs here, which is given one angle, which is making your job a little difficult here. All right. Therefore, sine of 35 is equal to opposite over hypotenuse. Opposite in this case would be F3y. Your hypotenuse would be f of 3. And multiplying both sides by f of 3 just to get F3y by itself, you'll get this is 0.57 f of 3. Okay. You notice here again, just like the x stuff, you have two unknowns, but that's okay. I'm going to go ahead and fill out my information in the y direction here. So kind of learn to trickle your work down. And if you run into unknowns, you probably have to think a little bit. So here, I'm just going to fill it in. I know that F3y in my work can now be substituted out for 0.57 F3. Okay. I know the left side of the equal sign are all known values. Well, we found that F1y is 246.2, which is right here in the blue. Right? And then we found F2y, which is 78.2, which is right here. So if you substitute out F3y for 0.57 F3, you notice here the only variable left in your work is f of 3, which is what part A is looking for. So I'll add the left side, which will give me 324.4. And then to get f3 by itself, I divide both sides by 0.57. That's why the 0.57 is the denominator there. And then punch in your calculator, and you should get a value of 569.1. And I'm just going to stop there because it asks for magnitude, so I don't need to give it any sort of direction. Okay? All right, so that's the first way to do part A. However, if I was doing this like on like a quiz or anything, I would not do all that work because that's a lot of work just to get there, okay? To me, I would just focus my attention in the y direction. Well, why am I focusing my attention in the y direction? Because I know that it's moving in the x direction, which suggests that the y direction, the net force in the y direction is 0. So I carry my work from the previous slides over here. So all this stuff in blue, I already showed you how to do it in the previous slide. So if you need to, go back in the video. If not, just use it, okay? Well, what I'm going to do is, I know the net force in the y direction is 0, so therefore I know my vectors upward and downward have to cancel out. So here, F1y is pointing up, and F1y is 246.2 at the bottom and the left of the screen. I'm also going to look at the diagram here, and I see that F2y is also pointing upward. So I'm going to go ahead and draw that up. And the magnitude of F2y is 78.2, which I already calculated in the first slide. However, if you look at the third diagram, or the third triangle here, F3y is pointing downward, so I'm just going to draw that pointing downward. But I know that everything has to cancel out. So here I have two arrows that are up. Well, to cancel everything out in the y direction, I need an arrow down, in this case, that's equal in magnitude, except it's just negative. So if you punch in your calculator 246.2, add 78.2, you'll get 324.4. Now it's negative because if you add all these numbers up, it has to give you 0 because the car is not moving up or down. It's just moving along the positive x-axis as being towed. Well, this information is super essential. I just found out, without overcomplicating stuff, that my F3y is negative 324.4. Well, like I said earlier, in geometry, they have to give you enough information to find all these missing legs and angle. Well, I'm given the angle here as 35 degrees. I just found out the opposite leg of that triangle, which is 324.4. Well, now that I know that, I can just solve for the hypotenuse super fast. Okay. Well, I'm going to solve the hypotenuse by doing sine. Well, why sine? Because referencing angle 35 degrees here, F3y is my opposite. So in geometry, opposite over hypotenuse is your sine. And f of 3 is my hypotenuse, which is what I'm trying to find. So therefore, I'm just going to do a little switcheroo. I want to move f3 up to the left because that's what I'm trying to find. I want to divide both sides by sine of 35. So I'm just going to move f3 up and then sine of 35 down. And if you punch into your calculator, you'll get the same value, which is 569.1. So I would use this approach. It just requires a little bit more thinking, okay? Now, to do part B though, part B says find the magnitude of the resultant force, or F subscript R for resultant, or just the net force. So I wrote down my net force function here for bird's eye view problem, right? This is a good starting point. However, I know for this one, as stated, the line of action is along the x-axis, which implied that the net force in the y direction is 0, so I'm just going to cross net force in the y direction out because it's just 0. Therefore, I'm just going to simplify this function, carry it down. Now you have net force squared, so you go to net force in the x direction square. Because of that, the exponent 2 is going to cancel out because it appears on both terms. So really, we have the statement, the net force is just the net force in the x direction, which makes sense because the car's not going up or down. It's just going to the right. Now, I know that in order to find the net force in the x direction, I need all of my x arrows, right? I have F1x, I have F2x, I have F3x. The only arrows that I'm missing is F of 3x because I already showed you how to find F1x and F2x in the previous slide. So I want to use the information in the triangle and find F3x. To find F3x, I'm going to use cosine of 35. Cosine is adjacent over hypotenuse. Again, if you look at this right triangle right here for F of 3, F of 3x is your adjacent leg because it's touching the angle. And then your hypotenuse F of 3. Here, we're trying to find F of 3x because we need all of the x's. We already found F3. F of 3, we calculate in part A, which is 569.1. And cosine of 35, if you do that correctly on your calculator, you'll get a value of 466.2 newtons. So that's F of 3. Well, now we know F1x, we know F2x, we know F3x. So all we have to do really is just add them all, okay? So here on the screen, these values were taken from the previous slide, 293.4, 216.2, and then I just found what F3x, which is 466.2, and if we add all that up, we'll get a value of 975.8 newtons, and it says magnitude, so I'm just going to box it as my answer. And if it doesn't say magnitude, you would say 975.8 newtons east, or positive 975.8. Okay, but magnitudes, I'll leave all the direction out. All right, that's it for this problem. Okay, stay nerdy, don't be whack.